Okay, we are going to do the correlation coefficient first. So a correlation coefficient describes how a linear relationship is x and y, how they're related. So the first thing we're going to look at is the correlation coefficient r. That's the letter that we use. So r is always between -1 and 1. Strong positive correlation, if it's positive, it's going to be close to +1. Strong negative correlation is close to -1. And then anything that's weak is close to 0. Do you see? All the weak is close to 0. And then the strong is out toward positive or out toward negative. A perfect linear correlation is going to have an R of 1, which will be a line. So all your dots will be in a line. Okay, so let's kind of guess what these correlations are. So let's look at the first one. Is this going to be positive or negative? The green dots. It's going to be positive, and it's kind of strong. So we are going to write positive. And I would say the R value is close to, let's do the little squiggly. I would say it's close to 9. And it's a positive R value. Let's look at the pink one. See how it's going downhill? So that's a negative correlation. We've already learned positive and negative correlation, but now we are assigning an R value to it. So the R here, is it stronger or weaker than the previous one, the green one? Are they closer together?
No, they're the same.
They're maybe the same, maybe a little bit closer, maybe the same. It kind of looks the same, right? So it's going to be negative 0.9. So we put that negative sign out front. The light blue one, the one in the very middle, it's like a typical scatter plot that has no correlation. So this is not positive or negative. We're going to call it more of a no correlation. X and Y is not related. So the R value there is going to be close to 0. It may not be exactly 0, but let's put R is approximately 0.1. Okay, the green one on the far left, that is more scattered out than the one right above it, but it's still positive. So let's write positive on it because it is going uphill, but it's just not as strong. So it's kind of a weak correlation. So R is going to be, I'd say closer to like 0.5, 0.5. So this is considered weak. The one above it would be considered strong. This one is no correlation. It's basically 0 correlation, very weak. Okay, the pink one on the far right, it's going downhill, so we know it's negative. But it's going to be weak. So R is going to be, it looks like it's a little bit weaker than the last one, but they might be the actual same points. So I'm going to say negative 0.5. So these are just estimates, but our calculator and also Desmos can find this for us. So some of you have already been using linear regression in the calculator, where you go to stat, edit, put in X, Y, then you go to calculate, linear regression. Raise your hand if you've done that. Okay. If you haven't, that's okay. We are going to go and do this actually on Desmos. It's actually a little bit easier on Desmos. So here are our instructions, okay? So linear regression in Desmos. Step 1, click the plus button. Step 2, add a table, input the values for X and Y. I'm just going through the steps and then we'll actually do it together. Step 3, in the next line, we're going to do Y1. Put a box around that. And then with squiggly, ilm X1 plus B. And then we can actually write our equation in y equals mx plus b form. It's going to give us what m is, which is our slope, and what b is. And we are going to write the equation. And we're going to put it into Desmos also to see how the line goes through the scatter plot. And then our correlation coefficient R is going to be what kind of correlation is it? Is it positive, negative? Is it weak, or is it strong? Okay, so let's do our first one. Okay, so I want everybody to go to Desmos, and we're going to follow the steps. So the steps say push the plus button. So I'm going to go to my Desmos. I'm going to push the plus button. And I'm going to add a table. Make sure you're following along with me, doing this at the exact same time as I am. Push the table. So I clicked this plus button. Then I clicked table. Okay, now we're going to put that table in. So let's type it. 0, 1, 2, 3, and 4. Then go to your Y's. 12, 13, 14, 14.5, and 16. Okay, now you want to zoom your graph out so you can actually see the points. So use your mouse or your fingers on your screen to zoom out and look at it the same way I'm looking at it. Can you see all your points?
No.
Zoom in, zoom out. Okay, and then we are going to put in that Y1 squiggly. So Y1, notice whenever I put 1 in, it actually goes down. So Y1, and then we want the squiggly. Squiggly. M X1 plus B. There we go. Where is the squiggly on y'all's keyboard? Right by 1. Do you have to hit shift? Okay. Okay, hopefully you see what the output is. So see how it gives you a line on top of your scatter plot? So this shows a line that goes along with all those points. So this is our linear regression line. So let's look at what the slope is. Slope is m, so look at parameters. As soon as you hit plus b, it gave us an output. M is 0.95 and b is 12. So let's say I want to put 0.95 as a fraction though. 0.95. Because slope is always as a fraction, right? Let's hit the fraction. So it's 19 over 20.
What is the
To the left where it has the 3, it gives you like a box / box. So then that actually converts it to a fraction for us. So in our notes, our equation, let's go ahead and write down what the equation is. M is 0.95, which is 19 over 20. And that came from our output on Desmos. And then we need to write our B. What's our B? Oh, it's 12. Okay, good. 12. So now we need to write our equation in mx plus b form. Y equals, you could put 0.95 x, but if you are typing in slope, you want to change it to a fraction. But I'm just going to keep it as my decimal, and it's fine. Plus to 12. 0.95x plus 12. If your answers, let's say it's a multiple choice question, your answers gave you fraction, that's when you would want to know that 0.95 is 19 over 20. Okay, and then our last question is, what is the correlation coefficient R? We're only going to go to 2 decimal places. So look back at Desmos. And it is not R squared, we want R. So 0.9904. Do y'all see that? R, not R squared. So 0.99 basically. 0.99. So that is very strong and it's positive. So it's a strong positive correlation.
how do you know if it's strong?
The closer it is to 1 or -1 is how you know if it's strong or weak. Okay, let's go to the next one. This is a word problem. Okay, the number of newly reported crime cases in a country in New York State is shown in the accompanying table, where X represents the year, Y represents the number of new cases. Use Desmos to make a scatter plot of the data. Find the linear regression equation, find the correlation coefficient, predict the number of new cases for year 2019. Okay, real quick, I don't want to deal with these big old X values, so I'm going to actually change this. I'm going to say years since, and I'm going to start it with 2010. Because I don't want to deal with those big X values. So I'm changing the X to years since 2010. So years since 2010, if it's 2010, this X value would be 0. So we're going to make this simpler. Years since 2010, if it's 2011, 1. 2012, 2013, and 2014. Okay. All right, so that is the table I'm going to use now. So go to Desmos.
Right?
Okay, you can refresh this page, you can clear them out, or you can keep them all in there. I'm going to clear them all out. Clear them all out, and actually I'm going to refresh the Desmos page also. Refresh your Desmos page, and the reason is because it's going to change it to X2 and Y2 if you don't. You hit the refresh button, the little circle with the arrow on it. Somebody around you can help. Okay, so let's hit the table. You'll need to put the table in. So 0, 1, 2, 3. Did we go to 4? Okay, 4. And now put in the values. So 954, 933, 904. Are you putting these in? 820 and 826. Did you put them in?
No.
Put them in. Make sure you have it put in. Okay, now we're going to put in that linear regression equations. One thing I need you to check though is on your table that you just created, make sure that this says X1, check yours, and Y1. If it doesn't, you can actually change them. Make sure it says X1 and Y1. Change it if you need to. Okay, so let's do Y1 squiggly MX1 plus B. So it's just Y equals MX plus B. The only thing that we're adding is the ones with the X and the Y and the squiggly instead of equals because we want it to be approximately. Okay, now zoom out and see. Whoa. Yeah, it is a big line. And you could do like this. So I can actually see the dots. Okay, so let's write what is our equation. Our slope is negative 36.9. Negative 36.9, so let's write our equation. So y equals negative 36.9 plus, what was the b value? 961.2. Okay. So that is our equation, our linear regression equation. We also need our correlation coefficient, R. Okay, R is approximately negative 0.90, or is it 1? Oh, 9.5 if we were to round. Okay, is this strong or weak? Strong because it's close to 1, but is it positive or negative? So it's strong, negative correlation. That just means it has a negative slope. Okay, then our last question. Use the model to predict the number of new cases for 2019. Oh, I forgot my X. Did y'all see that?
No.
X. Okay, sorry guys. Make sure you fix that so it has the X value there. Okay, so then our final question is predict the number of new cases for year 2019. So we are going to plug in X is, how many years since 2010 is 2019? 9.
17 years.
So we're going to plug this in. Y equals negative 36.9 times 9 plus 961.2. Okay, we can put this in our calculator or we can put it into Desmos.
I think Desmos.
I think that's what it is.
Okay, Desmos, negative 36.9 times 9 plus 961.2. I'm just plugging in. If it says y is this, then we plug in the y value and solve, but it says x is this.
Oh, 629.1.
629.1. So 629 new cases. We're going to round a whole number on that. So 629 new cases. Okay, that is it for our